Hello and welcome to Bhasi's IAS. Today we'll start with another new series with respect to geography, that is evolution of atmosphere. So in this video we'll try to understand what is about the atmosphere, how the primitive atmosphere was there and how the current atmosphere now has been evolved over billions of years ago. So billions of years ago it is believed that there was a blast in the space or the universe, and this universe is still expanding. This is how it is. We can understand by an example. Suppose there is a balloon which is not blown, that means there is no air inside. If we keep some dots, if we put some dots on this balloon and when we start blowing it, we can see that dots on this balloon is expanding by the space. Okay, like that, the same way universe is still expanding. Now this blast happened and there is lot of dust particles, pyrogates and minerals, everything started coming out, and there was a formation of a cloud happened and some particles came together and a cloud like formation called nebula happened. So this is like a nebula, lot of particles inside. Okay, inside this gaseous nebula we had molten magma. Okay, this is nebula. Now please understand what is the difference between magma and lava. It is same thing. When it is inside the earth's core, it is called molten magma. The moment it comes out, we call it as lava. Okay, this nebula, gaseous nebula, after few years, it got a spherical or a geoid shape. So what's the difference between a geoid, spherical or a circle? In the geoid shape, we can see that polar areas are horizontal and equatorial areas are vertical. So this is the signature or the characteristic of a geoid shape. Okay, and after few years, because of the gravitational pull of the earth, denser particles started concentrating towards the center of the earth, whereas lighter particles started moving towards the periphery of the earth. Okay, if this is center part, okay, we have nickel iron, like these things comes towards the center of the earth because of the gravitational pull of the earth, and periphery we have lighter particles. Okay, lighter particles are silica, aluminium, magnesium. This is what happened because of the gravitational pull of the earth. The items or the particles which are very dense or very heavy started moving and concentrated towards the center of the earth, whereas lighter particles which are density is very less started moving towards the periphery of the body. So this is how the primitive atmosphere is formed. We can call this entire body as primitive atmosphere. So what we understand now, there was a gaseous nebula which had molten magma inside. After few years it got a geoid or a spherical shape where polar areas are horizontal and vertical areas constitute the equatorial area, and after few years again there was a primitive atmosphere formed where denser particles or heavier particles started moving towards or concentrated towards center of the earth, whereas lighter particles or the denseless particles moved towards the periphery of the earth. Okay, this constitutes the primitive atmosphere. Now what happened is that after few years or after few millions of years, with time passed, we lost this primitive atmosphere. What we have now or what we live now is not primitive atmosphere. We have lost it. So now let us understand how we lost it. Okay, this is sun. Okay, this is Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. So we have 8 planets, and Earth at that time had primitive atmosphere where denser particles are towards the center and lighter particles are towards the periphery. But what happened is that during that time there occurred solar winds. Now also it is occurring at some time, but at that time it was very serious effect. That is, there is a lot of solar winds coming out of sunspots on the earth's sun surface. Okay, we can see here sunspots. Okay, a sunspot is something like a crater which is not uniform in size, or almost like a dip or a crater, which is caused because of many reasons. So solar winds normally originate from sunspot. Okay, from this sunspot wind started coming and flowing towards this side. Okay, while we understand the 8 planets, let me say it is the asteroid belt, and after Neptune we have Kuiper belt. Okay, so through this solar winds, Earth have lost all this primitive atmosphere, and what we have now is not primitive atmosphere. Now let us understand how did we reach this atmosphere what we have today. So we lost primitive atmosphere because of the wind from the sunspots of solar energy. We lost it, and after few years there started anaerobic bacteria which originated on the earth's surface. Okay, origination of anaerobic bacteria. So what is the peculiarity with respect to anaerobic bacteria? Anaerobic bacteria is a bacteria or living organism which does not need oxygen to live. Okay. So that time Earth had only carbon dioxide and water. So there was no oxygen. With that, this bacteria started evolving. So they started breathing and then living. Then carbon dioxide, water and so many particles started moving around in the atmosphere. And after few years, with the evolution, what has happened? Aerobic bacteria started coming into atmosphere. Aerobic bacteria. So what is the peculiarity with respect to aerobic bacteria? That bacteria or living organisms which need oxygen to live. So therefore, atmosphere now have carbon dioxide, oxygen, water and many other particles like nitrogen and all. Okay. So this is how the current atmosphere is evolved. Now let us understand a different feature in the atmosphere. Okay. We know that atmosphere consists of different or 4 layers now. That is troposphere, stratosphere, mesosphere, thermosphere. Thermosphere is also known as exosphere. Okay. We say that we can see the layers here. Okay. This is troposphere, stratosphere, mesosphere, thermosphere. Okay. Troposphere of the earth is the first layer as soon as from the surface of the earth. It is from around 0 to 8 to 18 kilometers. Okay. We'll come to that later, that why there's a range from 8 to 18 kilometers, because equatorial area of troposphere is literally a bulge kind where the distance is 18 kilometers. Towards the polar areas it is only 8 kilometers and towards the mid latitude it is only 13 kilometers. We'll come to that in detail when we study the layers of the atmosphere. Just as of now, you please understand that troposphere consists of range of area from 0 to 8 to 18 kilometers. Whereas stratosphere is there from 18 to 50 kilometers. Mesosphere is there from 50 to 80 kilometers and thermosphere is there from 80 to 480 kilometers. Okay. These are the different layers. Now we understand that there is a rate called lapse rate in troposphere or the first layer of the earth. Okay. So all activity or the everything happens in the first layer of the earth. So in the first layer of the earth, as you go up, okay, if this is a mountain or this is the altitude we can measure, as we go up the mountain or as we go up in the atmosphere, what we can understand is that temperature decreases. That is, with increase in height, there is decrease in temperature. This is called environment lapse rate or normal lapse rate or lapse rate. Okay. So we are talking about lapse rate. We can understand from here, this is also called the environment lapse rate, also otherwise it is called normal lapse rate, NLR. Okay. So what is NLR or environment lapse rate or lapse rate? In troposphere, with increase in height or as we go up, there is decrease in temperature. Okay. And it is said that with every 1 kilometer you move, there is a decrease of 6.4 to 6.5 degrees Celsius in temperature. That is, NLR can be written as 6.4 or 6.5 degrees Celsius decrease will be there. Okay. With increase in height, there is decrease in temperature. This happens only in troposphere, not into any other 3 layers. Please understand, NLR is applicable only in troposphere. So every 1 kilometers you move, you say that if this is 30 degrees Celsius at the ground surface level, 1 kilometer you move, there is 6.5 degrees Celsius decrease in temperature. 23.5, 17 degree, again 6.5 is reduced, 6.5 is reduced. So this is called normal lapse rate or environment lapse rate or simply lapse rate. Now let us understand, there are 4 layers in the atmosphere: troposphere, stratosphere, mesosphere, thermosphere. Okay. And we said that NLR is applicable only in troposphere. So NLR or normal lapse rate is applicable only in troposphere. So what about other 3 layers? What is the climatic conditions there? That we'll see now. Okay. In stratosphere, we have ozone particles present where it will attract the UV rays from the sun's rays. So because of the ozone layer is there, the layer which contains the ozone layer will get heated up. So that area will be hot or warm. So therefore NLR will not be applicable there. So what is NLR? When you go every 1 kilometer up, temperature will decrease by 6.5 or 6.4 degrees Celsius. So you will reach troposphere entire 18 kilometers and you will find tropopause. Okay. This area we can call it as tropopause, the border. This is tropopause. Okay. There is no air movement from the troposphere after tropopause to stratosphere. That is, till 18 kilometers only the movement will happen. So there is air movement is there in other layers, but very rarely or very sparsely situated particles are there. So in stratosphere, because of ozone layer, when sun rays coming, it will attract those rays and that layer become heated up or hot or warm. Therefore, NLR will not be applicable there, because when you go up with increase in height, what do you observe in stratosphere? There is increase in temperature also. So in stratosphere, what we observe is that with increase in height, there is increase in temperature. Troposphere, what do you observe? With increase in height, there is decrease in temperature. Stratosphere, with increase in height, there is increase in temperature happens because of the presence of ozone particles or the ozone layer. Now it comes to mesosphere. Mesosphere is the third layer from the Earth's surface. It is like 50 to 80 kilometers width or range is there. In mesosphere is NLR is applicable, but it will not happen how on the rate of NLR what happens, because the particles are very sparsely populated. That is, mesosphere, what happens is that with increase in height there is decrease in temperature, but is not much processes or not actions happen like this. Another important thing is that in troposphere, what we observe is convection of air. What is convection of air? This is convection of air. That is upward movement of air and almost coming back. That means warm air is going up, cold air is coming out. The cycle of this is called convection of air. Convection of air happens in troposphere, whereas in stratosphere, conduction of air happens. What is the difference between convection and conduction? Convection, circulatory movement or the vertical movement of air, and then almost like an unstable condition is formed, that is called the convection. What is conduction? Layer by layer transfer of heat, that is called conduction. Okay, that is, if this layer is heated, this layer will be heated, this layer will be heated, then this layer will be. So layer by layer transfer of conduction happens, transfer of heat happens, that is called conduction. Convection is applicable in two medium, that is gases and liquid, whereas conduction happens mainly in solid particles. Okay, coming back to mesosphere. Mesosphere, NLR is there but not applicable as per the rate, because with increase in height there is decrease in temperature, but there is sparsely populated molecules are there, so we cannot generalize it saying that it is NLR. Then the last thing is thermosphere. The last layer is thermosphere. It is almost from 80 kilometers to 480 kilometers. Thermosphere, what is the importance? There is a layer called ionosphere, or where electrons are available or present, and these ions will absorb what was the solar incoming radiation happening, and they also heat up the layer. Thereby, with the increase in height, you can see increase in temperature also in thermosphere or exosphere. So thermosphere, with increase in height, what do you observe? There is increase in temperature. So we are talking about four different layers: stratosphere, troposphere, stratosphere, mesosphere, thermosphere. In troposphere, it is around 0 to 8 to 18 kilometers. That is 18 kilometers in the equator, 13 kilometers in the mid latitude, and 8 kilometers in the polar regions. There NLR is applicable. That is, every 1 kilometer you go up 6.5 degrees Celsius temperature is decreased, and with increase in height, we can summarize by saying that with increase in height or altitude, there is decrease in temperature, or there is cooling down when you go up. But in troposphere, there is an area called tropopause, which acts as a wall in between troposphere and stratosphere. This tropopause will not allow the air to move beyond troposphere towards stratosphere. So air will go and almost like hit to, this is tropopause, air will go, it will go and hit towards the tropopause. So this happens in troposphere. Then we move towards stratosphere. Stratosphere, what happens is that presence of ozone layer is there. Therefore, NLR is not applicable, and apart from that, conduction is happening there. That is, layer by layer transfer of heat energy happens, and ozone layer absorbs solar radiation coming from the sun. That area become hot or warm. Therefore, with increase in height, there is increase in temperature in stratosphere. Then we comes to mesosphere. Mesosphere is almost like 50 to 80 kilometers in range. And in mesosphere, there is no such ions or extra layers present, no exceptions there. With increase in height, there is decrease in temperature, but NLR as such is not applicable because there is sparsely populated particles or air mass there. Last is thermosphere, is also called exosphere. This layer ranges from 80 kilometers to 480 kilometers, where we see an extra layer or exception called ionosphere. These ions or the electron particles will attract solar rays from the sun, and this area will become heated up. So therefore, we can say that 4 different layers, 4 different types of heating in the atmosphere happens. That's all for today. Hope this helps. Thank you.